The compound measure of density. Hi students, in this video you will learn about density as a measure of the mass of a substance compared to its volume. We will then use this knowledge to complete a set of density calculations in the context of real-life scenarios. We have seen in previous videos that compound measures compare two linked units of measurement in relation to one another. When we speak of the density of an object, we are comparing the mass of a substance in relation to its volume. Or said another way, density measured in grams per centimeter cubed or kilograms per meter cubed is a measure of the ratio of the mass of a substance compared to its volume. This can be summarized in the formula: density is equal to mass divided by volume. Therefore, to measure density, we need information about the mass of the substance as well as its volume. Let's consider example 1. A Snicker bar, my favorite chocolate, has a mass of 53 grams and it's cuboid in shape. When calculating volumes, it is useful to understand the dimensions of an object in terms of its length, width, and height. Since the Snicker bar is cuboid in shape, we can calculate its volume by applying the formula for the volume of a cuboid, which is volume of cuboid equals length times width times height. Since this Snicker bar has a length of 10 centimeters and a width of 1.5 centimeters and a height also of 1.5 centimeters, the volume of the Snicker bar can therefore be found by multiplying 10 centimeters by 1.5 centimeters by 1.5 centimeters to give us a volume of 22.5 centimeter cubed. It is noteworthy to remember that volume is a three-dimensional measurement. Since length, width, and height measurements are all in centimeters, when we multiply these dimensions, the centimeter measurements are also multiplied together. We say they have been cubed, as shown here. Raising the centimeter unit to the power of 3 indicates that volume is a three-dimensional measurement. Now we know the volume of the Snicker bar is 22.5 centimeter cubed. We can go ahead and work out its density, as we already have information about the mass of the Snicker bar. We can do this by accurately inputting the known pieces of this density puzzle into our density formula, which was density is equal to mass in grams divided by volume. We know the mass of the Snicker bar is 53 grams. We have just previously calculated that the volume of the Snicker bar is 22.5 centimeter cubed. When we input these values into our density formula, we can form the equation density is equal to 53 grams divided by 22.5 centimeter cubed. This gives us an answer of 2.4 grams per centimeter cubed to 1 decimal place for the density of the Snicker bar. Let's consider example 2. Leif from Pythagoras class, also quite keen on chocolates, alerted Dr. O to the fact that a chocolate bar is not always cuboid in shape. Dr. Omacobia, in agreement with Leif, informed the class we are just scratching the surface in terms of the differently shaped objects we could be asked to calculate the density for in our IGCSE maths and physics exams. And upon concluding that statement, Dr. O picked out a triangular shaped sweet from his box of quality streets and asked Leif, who was already on the edge of his seat, to calculate the density of the triangular shaped sweet. Leif confidently and excitedly walked up to the front of the class and assumed the teacher role, ignoring comments from his boys along the lines of, "Leif, don't eat the sweets, fam." Leif confidently told the class, "The first thing we need to consider is the mass of the sweet. It says on the inventory list that this particular sweet has a mass of 6 grams, and I'm going to take their word for it. What they have not told us though is that this sweet has a triangular prism shape, and we are not given the length, width, and height measurement of the sweet. So I'm going to quickly use this ruler to measure the sweet's dimensions now." After measuring, Leif wrote down the dimensions of the sweet on the whiteboard as follows. Base equals 3.5 centimeters. Height equals 3.5 centimeters. Length equals 0.5 centimeters. Leif then said, "The problem here, ladies and gents, is that we need to calculate the volume of this sweet based on these measurements. It's not like the previous examples involving the Snicker bar, which was cuboid in shape. This sweet is triangular in shape, so I really hope you man were paying attention when Dr. O was teaching this topic. Fortunately, Dr. O gave the class some time to refresh their memories on how to calculate volumes of cuboids, cylinders, and triangular prisms. And it is important to let you know at this juncture, you may want to pause the video and recap this too. Okay class, let's begin. Based on the dimensions kindly measured out by Leif for the triangular suite on the board, we can work out the volume of the triangular prismed shaped suite by employing the following equation. Volume of triangular prism is equal to cross-sectional area times length. Since the cross-sectional area of the suite is triangular, we need to recall the formula for the area of the triangle, which is area of triangle is equal to base times height divided by 2. When we input the base and height measurements for the triangular shaped suite into the formula as follows: 3.5 centimeters for the base times 3.5 centimeters for the height, and then divide our answer by 2, we determine that the cross-sectional area of the suite is 6.125 centimeters squared. Now that we know the cross-sectional area of the triangular shaped suite is 6.125 centimeters squared, we can multiply this answer by the suite's length, which was 0.5 centimeters, to produce the calculation as shown here. 6.125 centimeters squared times 0.5 centimeters, giving us an answer of 3.0625 centimeter cubed for the volume of the triangular shaped suite. Finally, to calculate the density of the triangular shaped suite, we need to accurately input the pieces of this density puzzle into our density formula. So the density of the suite will be 6 grams divided by 3.0625 centimeter cubed, which gives us an answer of 1.96 grams per centimeter cubed to 2 decimal places. Let's consider example 3. Azaria from Pythagoras class put her hand up to ask a question. Sir, so far we have looked at calculating the density of suites that have been cuboid and triangular in shape. What about suites that are circular in shape? And on that note, Dr. Omakobia picked out another suite from his box of quality streets and asked Azaria to have a go at calculating the density of a circular shaped suite. Azaria confidently walked to the front of the class and held up the suite and asked the class to describe its shape. Isaiah shouted out, "It's circular in shape." Azaria laughed and said, "Isaiah, you are not wrong, but let's elaborate on this a bit more." Yes, the suite is circular in shape, but how would you describe its 3-dimensional shape? Isaiah responded cheekily and said, "Well, if we are trying to get technical here, we could see that the suite is shaped like a cylinder that has been cut into a smaller piece. Imagine cutting a Swiss roll into a smaller piece, for example." After Azaria was satisfied that the whole class could agree that the suite was cylindrical in shape, Azaria rather astutely took the wrapping of the suite and weighed it and worked out that its mass was 4.5 grams. She then used a ruler and measured the suite's dimensions and added annotations to a projected image of the suite on the board as shown here. Azaria worked out that the suite had a circular diameter of 2.4 centimeters and therefore a radius of 1.2 centimeters and a length of 0.4 centimeters. Azaria also informed the class, "We need to let the formula for density guide us. We know the mass of the suite is 4.5 grams, but we don't know its volume. So let's organize the information we do know into the density formula as shown here." Dr. Omakobia was really impressed at this point and reminded the class to refresh their minds on calculating the volume of a cylinder. Why not pause the video, open up a new tab and watch our video on calculating volumes of shapes if you need a recap too. Okay, let's review our answer for the volume of the cylinder. Okay, when calculating cylinder volumes, we need to find out the area of the circular front face, that is, the cross-sectional area, using the formula pi times radius squared as shown here, which gives us an answer of 4.5 centimeters squared to 1 decimal place. We can then convert this answer to a three-dimensional measure of volume by multiplying the circular cross-sectional area by its length of 0.4 centimeters. This will give us a volume of 1.8 centimeter cubed to 1 decimal place for the cylindrical shaped suite as shown here. Okay, now we have all the information we need to calculate the density of the cylindrical shaped suite. So let's recap and consider the density puzzle pieces we have. Azaria showed us that the mass of the suite is 4.5 grams. We have just calculated that the suite's volume is 1.8095573,685 centimeter cubed. We just need to accurately organize this information into our density formula as shown here. This will give us a final answer of 2.5 grams per centimeter cubed to 1 decimal place for the density of the suite. Please note, we should always round the final answer and avoid using rounded numbers during the calculation to avoid rounding more than once. Okay, let's look at the benefits of using a scientific calculator properly. For ease of calculation, in an exam scenario, we need to take advantage of the fraction key as shown here. By inputting all of our values just like this will give us our answer for density instantly. Okay, let's consider one last example. A powerlifter is attempted to squat 8 25 kg weight plates for a new personal record. One weight plate has a volume of 7,693 centimeter cubed. Why not pause the video and have a go at calculating the combined density of the 8 weight plates? Okay, so in this question, we have been told each weight plate has a mass of 25 kilograms. And since there are 1,000 grams in a kilogram, 25 kilograms can be represented as 25,000 grams. Since there are 8 weight plates in total, we need to multiply 25,000 grams by 8. We know the volume of one weight plate is 7,693 centimeter cubed. Therefore, to calculate the volume of all 8 weight plates, we need to do 7,693 centimeter cubed multiplied by 8. In order to calculate the combined density for all 8 25 kg weight plates, let's organize all of this information into the density formula using our scientific calculator as shown here. So we have density is equal to 25,000 grams times 8 in brackets divided by 7,693 centimeter cubed times 8. This gives us an answer of 3.25 grams per centimeter cubed for the combined density of 8 25 kg weight plates. So far in this lesson, we have learned that density is a measure of the ratio of the mass of a substance compared to its volume. We completed a range of density calculations involving suites with cylindrical, cuboid, and triangular volumes. I really hope you've enjoyed this lesson as much as I have enjoyed preparing it. Why not think about some real life scenarios where knowledge of density calculations is useful in life? Maybe for perhaps explaining to the whole family why it's possible to float on the waters of the Dead Sea. This is an ABBA Academy Scripts production. Don't forget to smash the like button and subscribe for more Igcse maths content. For online group Igcse maths tuition, don't forget to visit www.abbaacademytuition.com.